plural for the word matrix. Matrix. And so if you have one matrix, you call it matrix. If you have multiple, you call it matrices. So before even diving into the technical details of what a matrix is, let me tell you what's the history behind it, what sort of need arise for which matrices were invented. So matrices, just like any other mathematical tool, were designed to solve a problem, and that was to solve linear equations. So linear equations in 2 variables, in 3 variables, in 4 variables, in n variables. You could use matrices as a powerful tool to solve them. But ever since their discovery, ever since the mathematical community started using it, it has not just been restricted to solving equations. It has been used in all sorts of sciences and the humanities. You have matrices being used in computer science. You have matrices being used in cryptography, economics. They form the backbone of the spreadsheet programs that we have, and whatnot. So technically, a matrix is just an array or a collection of numbers or functions. And there are a special sort of array. There are rectangular arrays. Rectangular array. And what I mean by that is, let's take an example. So you have a rectangular array. Let me write the word rectangular in white. You have rectangular array. Rectangular. So the shape sort of resembles a rectangle. So you can have a matrix which is usually represented by a capital English letter. So let's say capital A equals the matrix some numbers or some functions. So you could put in any numbers there. You could put in complex numbers as well. So I minus 2, where I is the square root of -1, 3 minus half, root 2 pi, root 3. That's a nice matrix. It satisfies the property of being called a matrix. You could also have functions right there. You could have written, instead of, let's say, 3, you chose to write x cubed, and x could be any number, and you input it and you get an output at this location right there. So not just you can just like specify matrices as a mathematical tool, but you can also see matrices. You can also use matrices in real life to keep track of things. So let's say a person A has 5 notebooks, and then you make a matrix for that. So you say, within the square braces, within the square brackets that we use for matrix, that's the sort of convention, you write 5. Okay, now A has 5 notebooks, continue, and 2 pencils. So now you sort of specify that, okay, the first column will contain notebooks and the second column will contain pencils. And for notebooks there are still 5, but for pencils there are 2 pencils. So this is a matrix. This is a matrix of one row, since there is just a single row, and 2 columns. And you can take this further. Let's say there is some other person, B, who has 3 notebooks, and 3 notebooks, that's a plural, and he has 3 pencils. And you can write a matrix for him as well. So let's say you write 3 and 3. 3 for the notebooks, and this purple 3 for the pencils. And what you can do is you can combine these two together to form a single matrix. And you can specify what rows do what columns do what. So you write 5, 2, 3, 3, and you say that the first column represents notebooks, and the second column represents the pencils, and the first row represents A, the things belonging to A, and the second row represents the things belonging to B. And so if you can store this really nicely within computers, and that's sort of is kind of the way how computers run these computations. When you want to figure out how many pencils B has, you go in the row of B and in the column of pencils, and you figure out that the number is 3. Great. So that's what a matrix is. Now, what you can do is you can specify something that's called the order of the matrix, order of the matrix. And the order of the matrix is kind of like it represents a family of matrices. So let me show you what I'm talking about. So let's say you have a matrix. Let me put in some random numbers in here. So 1 0 0 0 2 3 5 root 2 pi. Now in this matrix, let's call it by A. In this matrix, you have 3 rows and 3 columns as well. So 3 rows and 3 columns, and the order of this matrix would be 3 cross 3. That's the order. So basically, you take any matrix. If you have 4 rows and 2 columns in a matrix, the order becomes 4 cross 2. That's what the order of the matrix having 4 rows and 2 columns would be. And not only that, you also have a sort of you sort of generalize the idea of the order further into including all sorts of numbers that you can have. You can have hundreds of rows and hundreds of columns, and the idea would still remain the same. You would write the number of rows cross the number of columns that you have. So if you ever want to figure out number of elements, all of these numbers are called the elements of the matrix. Elements of matrix. Every number in the matrix A is called an element of the matrix A. So if you want to figure out the number of elements of a matrix having 4 rows and 3 columns, and you can draw a matrix like that. So you can have 1 2 3 4, and again you will repeat that for 3 columns and 4 rows. And when you have a matrix like that, so you can count it. There is one way that you can count it, and that will be 12. There is other way that you see that this is nothing, just the product of m times n, the number of rows by the number of columns. So in this case, it will be 4 times 3. That's just 12. So in general, a matrix of the order m cross m has m times n elements. M times n elements, or mn elements. M cross n matrix has m times n elements. Now sometimes you also need to figure out how to give a unique identity to each element of your matrix. So in the matrix that we had, let's just use that matrix for now. So in this matrix, let me erase the rows and the columns. In this matrix, you can assign a variable to each of these elements. So for this number 3, right there, it lies on the intersection of the second row and the third column. And so if you assign a variable named small a to the elements of this matrix, the name for this element right here would be A23. So it represents, firstly it writes the row, and second it writes the column of that element. So in this matrix right here, if you want to figure out if you assign a value aij to each of these, each of these elements where where I represents the rows and J represents the column, then A32 would be the intersection of the third row, and the second column, and that's the number square root of 2. You could also generate the elements of a matrix using a certain function. So if you have let's say A equals Aij, and that is equal to AI, and you say that Aij is equal to I times j if I is not equal to j, and 0 if I is equal to j. So let's analyze the expression a little bit. So this says that the matrix A has elements which we will call Aij, where I represents the row number and j represents the column number. And in that array, in that matrix, you sort of have a function generating each entry. So let's say you wanted to generate a 3 by 3 matrix out of this. So what you would do is you could draw a 3 by 3 matrix by the following. So A11, you have A11 here for the first row and the first column, A12 for the first row and the second column, and A13 for the first row and the third column. And similarly, you fill out all the 9 entries, 9 elements that you would have in this matrix. And you can start off by replacing each variable by the exact expression that you have. So A11, so I and j in this case are equal, so it's just equal to 0. It's equal to 0. So you write 0 for it. And then you see that A22, A33, both have their i's and j's equal, so for all of them you write the number 0. 0. And for the rest of them, you know that you just have to multiply the row number by the column number. So A12 would be 1 times 2, that will be 2. A13 would be 1 times 3, that would be 3. And then A23 would be 6. And you can continue doing that again. And this side would just be the same as what we have done on the upper part of this matrix. And here you would have 6, 3, and 2. So in this video, we had a little bit of introduction to matrix, and we started talking about the order of the matrix, and we saw an example of how we can generate the elements of the matrix using a certain function, and you could have any function here given as you may wish. So I'll see you in the next video, where we will continue talking about matrices, and we will talk about the various types of matrices that we have, special types of matrices. I'll see you in the next one.